All right, in this lesson, we're going to do something a little bit different. We're going to look at a technique for finding derivatives called logarithmic differentiation. So what is logarithmic differentiation? Well, it's an alternative way of finding derivatives of complicated functions, or maybe not so complicated functions. And so basically what you're going to do is you're going to use properties of logarithms in order to manipulate the function that you have to make it less complicated and then find its derivative using the natural log rule. So keep in mind properties of logs. So if I have natural log of x to the nth power, I can rewrite that as n times natural log of x. So I'm just bringing the exponent out to the front as a coefficient. If I have two things divided by one another inside my natural log, say natural log of x divided by y, I can rewrite this as natural log x minus natural log of y. If I have multiplication inside my log, I can have natural log of x plus natural log of y in this case. So let's look at an example because I think logarithmic differentiation really does warrant an example rather than just some arbitrary definitions. So let's take this y equals the cube root of x times e to the x divided by cosine x. Could I use a chain rule to find the derivative? Absolutely, but why would you want to? Because whenever you do the chain rule, you're going to take the derivative of the outside, repeat the inside, but when you go to find the derivative of what's inside, you're going to have to use a quotient rule, plus you're going to have to incorporate a product rule into your quotient rule, and then things just get really, really messy. So what I could do is I could take the natural logarithm of both sides. So let's do that. Let's take the natural log of y equals the natural log of the cube root of x e to the x divided by cosine of x. What I can do at this point is I can use some properties of logarithms in order to really simplify this function down to where I have some really nice, easy logarithms that I can differentiate using my log rule. So this is natural log y on the left-hand side. And that's equal to, if I use the power rule for logarithms, or it's probably not a good idea to call that power rule since we have a power rule for derivatives, but if I use the property that involves powers inside a logarithm, this natural log of the cube root of x e to the x over cosine x, if it's a cube root, remember that's the same thing as the 1/3 power. So let's bring the 1/3 out as a coefficient. So this is 1/3 natural log of x e to the x over cosine x. Okay, inside now I have a quotient of two functions. So essentially what I have is natural log y equals 1/3 natural log of x e to the x minus natural log of cosine x. So all I'm doing is I'm breaking apart my quotient here as a subtraction of two separate logarithms. So this is natural log y equals 1/3 times natural log of x plus the natural log of e to the x, so natural log of e to the x minus natural log of cosine x. I can simplify this maybe just one more step just for convenience. So natural log of y equals 1/3 of natural log x plus x natural log e minus natural log of cosine x. And now I'm ready to find some derivatives. So whenever I take the derivative of natural log of y, I could use a technique called implicit differentiation. I know we haven't gotten quite to that point yet, but really what you're doing is we're taking the derivative of what's inside. So the derivative of y is y prime, and I divided that by y. Then I have 1/3. The derivative of natural log x is just 1 divided by x, plus here I have the derivative of x, which is 1. Natural log e is its own identity, and that's the value 1, minus natural log of cosine x, so this is negative sine x divided by cosine x. And if I wanted to, I could rewrite that as negative tangent. So let's simplify just a little bit. So I have y prime over y equals 1/3 1 over x plus 1 plus tangent x. So keep in mind the negative, negative is going to create the positive, and sine x over cosine x is tangent. So what I have here is something really nice. I have y prime divided by y equals 1/3 1 over x plus 1 plus tangent x. So the trick here is I still have this pesky y in my answer. Well, what I'm going to do is I'm going to rewrite my function, but I'm just going to multiply both sides by y. So y prime is equal to 1/3 1 over x plus 1 plus tangent x, and I'm going to multiply that by y. Well, what is this y? Well, y is exactly what we started with in the beginning. So I'm going to just simply replace y with what it was originally equal to. So this is 1 over x plus 1 plus tangent x times, and then I started out with the cube root of x e to the x divided by cosine of x. And that's logarithmic differentiation. It's simply taking the properties of your logarithms that you know already from pre-calculus and applying them to each side of your function, and then differentiating very easily with the natural log rule, which is just the derivative of the inside divided by the inside. So this is logarithmic differentiation. Use it whenever you have really complicated chain rule functions or really complicated quotient functions that you don't want to mess with.